Today we will be talking about moving objects and their relation to other objects. So, in physics we deal with a lot of moving things. Let's say either it's a cart moving along a railway, or maybe it's a ball rolling down an incline. So it's always very important to mark our reference points. First of all, usually we use this by creating an XY axis. This lets us have a reference point to where the object started, where it ended, and makes the problem much more easier to approach. Now, of course, sometimes a problem, however, will ask you how something else is moving in relation to the other object. So let's say you might be following the cart, and that would be the XY plane could maybe be inside the cart. And that means it would move along with it. Or in this case here, you could define your ball as this way, where going down the slope is in the X direction, and then the normal force, which is always pushing up, would be the positive Y. Then there's other places where, for example, where you have an XY coordinate plane and there's an object moving through that coordinate plane. In that case, the coordinate plane stays still while the object moves across it. Whereas something here, like the ball, the coordinate plane moves along with the ball in reference to the ball while the other things are moving. This can be a little confusing, so it always helps to draw out the problem first. So let's take a crack at one of these problems. All right, here we go. So we have a cart over here. Person 1 holding a ball. Then we have person 2 over here. He's not on the cart. He is also holding a ball. The cart is moving in this direction. And we're going to define our XY plane here. So this is X. So it is moving in the positive X direction. No movement in the Y direction though. Okay, so student 1 is standing on the cart holding a small stone, while student 2 is standing at rest on the ground. The cart is moving at a constant speed v in the positive x direction, as indicated by the coordinate system shown. Student 1 drops the stone precisely when passing student 2. So as this guy passes student 2, this stone is over here and it's dropping. Precisely when, which of the following best represents the path of the falling stone relative to student 1 and the path of the falling stone relative to student 2? So in relative to student 1, the stone would fall as he's moving. The ball, it also has a velocity as he's moving along with the whole system. So if you moved along with him, as he dropped, he would see the ball go straight down. Now, however, for student 2, since he is on the ground, he sees the whole, the coordinate plane is fixed to him. So as he sees the whole system move by, so wait, I forgot to label, here's XY, XY. This is for person in person to reference 1, and this is for 2. So as he moves by, he drops it. But since when he drops it, the whole system is still at some sort of velocity, it would move in this direction while moving down. And then the only option that has this is option C.